This video will show you how the three axes and their components all come together on the main metal frame. We begin with the x-axis and the linear guides for the z-axis. These guides fit into the linear bearings on each end of the x-axis. Once they've been placed, slide them in and out and make sure they move freely. If they don't, your linear bearings inside the x-axis might be misaligned. Next we get some printed parts and place them next to the z-axis stepper motors already on the main metal frame. Trim them if there's excess printed material, then make sure they clip in properly. You can use the soft hammer to tap them in. On top of these, carefully mount the assembled x-axis and the z-axis guides. Thread the z-axes through the holes at the top, then fit them into the printed parts below. Make sure the ensemble is facing the right way. Tap carefully with a soft hammer for a good fit. Keep in mind there's a lot of wiring now, so position it in a way that it won't interfere. Then place the printed pieces into position. If they don't slot in at first, they might need some trimming to remove excess material left over from the printing process. Once in position, they're held in place by a screw, washer and nut combination. Time to finish up the x-axis. Slide the whole axis up and down and tap gently with a soft hammer if it feels stuck. Once it's sliding freely, we tighten those screws left finger tight at the end of the assembly of the x-axis. Again, when tightened, check to see if the x-axis components slide up and down freely. The following step is to place the threaded rods into position. Each rod should slide in through the top of the printed piece unimpeded. You must then screw it into the nut inside one of the printed components on the tip of the x-axis. The rod then continues to tighten downwards and inserts into the flex coupling. Once it's tightened all the way, fix it in place by tightening the socket set screws inside the coupling. Do the same on the other side. With this done, you must now check if the nozzles are not coming into contact with the build plate. If they are, rotate both flex couplings at the same time in a clockwise motion. You need about 8 mm of clearance since you'll be adding the glass plate later. Onto the drive belts. You have a single coil that you need to measure out and cut. We start with the y-axis belt. Thread the end of the belt drive into place as you see here. Note that the belt has an orientation. When it's looped around the pulleys, it must have its teeth facing inward so as to have traction on the tooth pulley. The belt tips are held in place with cable ties. Consult the manual to ensure you use the correct ones. Once fastened, cut off the tip of the cable tie with cutter pliers. Loop the belt around either pulley. Stretch it and then cut it. Use the build plate edge as the reference for the cut. Then fasten the end onto the bracket just like you did with the other end, apply a cable tie and cut the excess of both the tie and the belt. You now tension the belt by carefully pulling on the stepper motor and tightening the screws. If they've been tightened, loosen them first, stretch the belt and retighten. The belt must have some play in it and not be too stretched. Do exactly the same for the x-axis drive belt. First you apply these small components on the x-axis. You may need to file away spots of thick paint. Loop the belt tip, making sure the teeth face inwards when looping the belt, and fasten with a cable tie. Loop the belt around the pulleys and fasten the other end. Note the two small metal plates are held in place by the tension belt. To finish, stretch using the stepper motor, then tighten the motor screws. This phase of the assembly is now complete.